All right, so we're going to start looking at some min-max problems. These are generally word problems where we're trying to find a minimum or maximum. Often they're practical, at least semi-practical. In big business, these are very practical, but probably a lot more complicated than the ones we're looking at here. So we've got a farmer who wants to make a rectangular enclosure. She has 240 meters worth of fence material. What dimensions give her the maximum area? So we're going to have some kind of rectangle. We're going to have a width and a length, and we're going to have those width plus length plus width plus length equal 240. So what we're going to do is form a couple of equations and then eliminate some variables and get the answer. So we've got 2 lots of our width plus 2 lots of our length equals 240. And I'm just going to rearrange that now to save me some time. I'm going to say width is equal to, if I divide through by 2, I'm going to get W plus L equals 120, and then minus off my L. Okay, now, the other thing that we care about is what's the maximum area. So we don't know what the area is going to be, but we know that it's going to be width times length. So now I'm going to use this here to get rid of my W here. So I've got 120 minus L times by L. And I want to maximize this area. So I want to check my extreme values and any stationary points. Well, my extreme values is when my length is going to be 0, or when my length is half of the total, because I've got to do it twice, 120, and then I've got to work out what my stationary point is. So let's work out my stationary point, dA, dL. Now, if I expand this, I'm going to get 120L minus L squared. So when I derive that, I'm going to get 120 minus 2L. And I want that to be 0 to find my stationary point. So let's do some rearranging. I've got 120 equals 2L, or L equals 60. So what I'm interested in is the 3 points when L is 60, when L is 0, or L is 120. So let's have a look at those values. So L equals 0. So my area is going to be, going back to this, you can see it's 120 L minus L squared. So 120 times 0 minus 0 squared, well, that's going to be 0. So if we're going L of 60, my area is going to be 120 times 60 minus 60 squared. And that one, I really need to get a calculator out to do. So I'll just quickly do that. 120 times 60 minus 60 squared. And I get an area of 3,600 meters squared. And my final option was the other extreme, is where I put all the length into my, all the fencing into my length. And so my area here is going to be 120 times 120 minus 120 squared. Well, I can see that's 120 squared minus 120 squared, it will be 0. And really logically, I could annihilate those two very quickly and realize that this here is my optimal. So length equals 60. If my length equals 60, if I go back to my equation here, my width is going to be equal to 120 minus 60, which equals 60 as well. And I've got an area of 3,600 square meters. Let's put some units on. So we end up with a square.